lot of people still think airplane toilets work in the simplest way possible. You press a button and everything just disappears into the sky. Sounds logical, right? You're thousands of meters up in the air. Where else would it go? But if that were actually true, living under flight paths would be a very different experience. And from a safety and environmental standpoint, it would make absolutely no sense. In reality, an aircraft toilet isn't just a hole to the outside. It's a fully engineered system with valves, tanks, sensors, and pressure control. But it didn't start that way. To understand how we got here, we need to go back to the very beginning. In early aviation, comfort wasn't really a priority. Aircraft were small, flights were short, and toilets simply didn't exist. If you needed to go, you waited. As air travel evolved, though, that quickly became a problem. Flights got longer, more passengers came on board, and just hold it stopped being a realistic option. So the first solutions started to appear, and they were about as basic as you can imagine. Buckets. Yes, literally buckets. From an engineering perspective, that's about as simple as it gets. But in terms of hygiene and safety, not great. Turbulence, tight spaces, human error. All of that made these early setups unreliable and, honestly, pretty unpleasant. It became clear, if aviation was going to scale, it needed a proper built-in system. One of the first real engineering solutions was the gravity-based toilet. The idea was surprisingly simple and kind of clever. The toilet was connected directly to a valve in the aircraft's fuselage. You pull a lever, the valve opens, and everything is released outside, straight into the airflow. No pumps, no complex systems, just gravity and airflow doing the job. Engineers liked it because it was lightweight and mechanically simple. Fewer parts meant fewer things that could fail. Passengers didn't mind either. Airflow carried odors away almost instantly. But this simplicity came with a serious downside. First, the system wasn't fully controlled. Not everything was removed cleanly, and odors could still be an issue. Then came more advanced designs that used water for flushing, which introduced a new problem: weight. In aviation, weight is everything. Every extra kilogram means more fuel burned. So the more water you carry, the more expensive the flight becomes. On top of that, systems with storage tanks brought another challenge: capacity. If the tank filled up, the toilet simply stopped working, and on long flights, that could happen before landing. Now imagine that scenario mid-flight. Add to that leaks, sealing issues, and maintenance complexity, and it was clear the system still wasn't good enough. And then came one of the strangest problems in aviation history. To control odor and bacteria, aircraft started using a special chemical fluid, the well-known blue juice. It disinfected, reduced smells, and helped break down waste. But early systems weren't perfect. If there was even a small leak, that fluid, along with the waste, could escape to the outside of the aircraft. And at cruising altitude, where temperatures can drop to around -50 degrees Celsius, it freezes instantly. That's how something called blue ice was formed. Frozen waste mixed with that blue chemical fluid. In some cases, it would build up on the aircraft's exterior and later break off during descent. Yes, there have been real incidents where these frozen chunks fell to the ground, sometimes onto houses, sometimes near cars. Rare, but very real. And stories like that made one thing clear: this wasn't something you could just improve. The entire system needed to be rethought, and that solution was just around the corner. The solution came from a surprisingly simple idea. What if, instead of using water to flush waste, you remove it using air? That's exactly what engineers did. In the 1980s, with aircraft like the Boeing 757 and 767, vacuum toilet systems were introduced and quickly became the standard in commercial aviation. From the outside, these toilets look completely normal. Same bowl, same button, but inside the system works very differently. First, there's almost no water involved. Each flush uses only about 100 to 200 milliliters, just enough to wet the surface. The bowl itself is coated with a smooth, non-stick material, similar to Teflon, so nothing sticks. Now here's where things get interesting. Under the bowl, there's a sealed valve. Normally, it stays closed, isolating the cabin from the waste system. But the moment you press the button, the valve opens for a split second. A powerful airflow is created, and everything is instantly pulled into the system. It works a bit like a vacuum cleaner, but much more powerful. And that loud whoosh sound you hear, that's not water. That's air moving rapidly due to a pressure difference, which is why it's so sudden and intense. Once the flush is complete, the valve closes again and the system is fully sealed. All waste is then transported through pipes into a storage tank called the waste tank. Now, the key question: where does that vacuum actually come from? This is where things get really clever. On the ground, the system uses a vacuum generator, basically a pump that creates low pressure inside the system. But once the aircraft climbs to cruising altitude, physics takes over. Outside the aircraft, air pressure drops dramatically. At around 10 to 11 kilometers, it's several times lower than inside the cabin. Inside, the cabin is pressurized, roughly equivalent to being at 2,000 to 2,500 meters above sea level. So now you have a natural pressure difference: higher pressure inside, lower pressure outside. And engineers use that difference. The waste tank is effectively connected to this lower pressure environment, so when the valve opens, air, along with the contents, rushes toward that lower pressure area. In other words, the system starts working almost for free. That's why, at altitude, vacuum toilets are even more efficient and don't rely as much on mechanical systems. The result is a very efficient design: minimal water usage, reduced weight, fully sealed system, and smart use of existing flight conditions. And that's exactly why vacuum toilets became the standard in modern aviation. Now, just to be clear, waste doesn't get released into the sky. Everything ends up in that sealed waste tank. This tank is built to handle pressure differences, vibrations, and extreme temperatures. To prevent freezing at high altitude, both the tank and the pipes are often heated. There are also sensors that monitor how full the tank is. If it reaches capacity, the system can automatically disable the toilet. After landing, a service vehicle connects to the aircraft through a dedicated panel. It will remove the waste, clean the system, and prepare it for the next flight. And here's an important point: there is no way for the crew to dump waste mid-flight. All access points are external and can only be operated on the ground. So the idea of pilots secretly dumping waste over the ocean, that's just a myth. Interestingly, aircraft aren't the only vehicles dealing with this problem. Cargo ships also need waste management systems, but their approach is completely different. On a ship, weight isn't a major concern. There are no extreme pressure differences and temperatures are far more stable, so they can rely on simpler systems: storage tanks, gravity, and sometimes biological treatment. Aircraft, on the other hand, operate in a much harsher environment. Every kilogram matters. Pressure changes constantly, and outside temperatures can drop to -50 degrees Celsius. So the design priorities are completely different: minimal water, maximum sealing, and reliance on vacuum systems. You could put it this way: on a ship, it's about simplicity and endurance. In an aircraft, it's about efficiency and control under extreme conditions. Now, a logical question. If there's water on board, how safe is it, actually? The short answer: yes, it's regular potable water. It's loaded onto the aircraft on the ground using specialized service vehicles, and it goes through strict quality control. There are multiple layers of safety: regular water testing, system disinfection, and a limited storage time, typically up to 72 hours. On top of that, the water system and the waste system are handled completely separately. Even ground personnel aren't allowed to service both at the same time. But there is a small catch. That water still passes through onboard tanks and pipes, and in rare cases that can affect its quality. That's why many pilots, for example, prefer bottled water. As for tea and coffee, they're generally considered safe since the water is heated during preparation. And here's a story related to that famous blue liquid. In some cases, especially when people were flying for the first time, not everyone fully understood how airplane toilets worked, and sometimes things got a little unexpected. Passengers would see that blue liquid in the bowl and assume it was just water. There were cases where people actually tried to wash their faces with it, and yes, they walked out of the lavatory with bright blue faces. It sounds like a joke, but stories like this have been shared by pilots more than once. If you step back and look at the bigger picture, the evolution of airplane toilets is actually a great example of engineering progress. From buckets to systems that rely on pressure differences and vacuum, working efficiently at 10 kilometers above the ground. Today, it's clean, sealed, and highly optimized, and most passengers never even think about it. So here's a question for you. Do you drink tea or coffee on airplanes? Or do you prefer to avoid onboard water altogether? And be honest, how many of you still flinch a little when you hear that loud whoosh?